Well, hello, Internet. So today we're going to talk about VXLAN, and I have in parentheses here all the things. So uh, let's first talk about what I'm going to try and accomplish with my little lab setup, and we'll talk a little bit about VXLAN, but I want to dive into configuration first, then we'll talk more about operation. So let's talk about the problem. So the problem is we have these spine switches. Let me get my pen just right. We have these spine switches. We'll do a line like that. You know what? Even better. Let's draw a good line. Let's do it like this. So you have these spine switches. Then down here we have our leaf switches. And you can think of this as kind of similar to how you would have your core and distribution switches. We'll separate them like this. All right, and then down here you have any number of hosts, and any type of host. I mean, these could be physical hosts, they could be virtual hosts running on some sort of hypervisor. But in this lab, they're just called hosts. Actually, I think in GNS3, they're still labeled as PCs. But it doesn't matter. The objective here is, one, we want all these hosts, and I'm going to put a circle around them. We want all these hosts to be on the same segment. And in this lab, the segment's going to be 192.168.0.0/24. I probably could space those numbers out more if I wanted to, but that's far apart enough. So the segment's going to be 192.168.0/0. They should all appear to be on the same LAN. And then the other part of this lab is that with these 4 spines or core switches, we want to make sure that the links between spines and leaves, every single one of them is forwarding. Now, with the traditional spanning tree, you run into a lot of problems with that, mainly that you can't do it. You can't do this with traditional spanning tree. With VPC, I mean, you could virtual port channel some of these links together and get 2 forwarding, and then, if there is different VLANs, you might be able to do something where you're load sharing VLANs. You have one VLAN active on one trunk and one VLAN active on another trunk, but that doesn't help this segment down here. So for this segment down here, traffic between all these hosts has to go through the leaf and spine layers, and all links have to be forwarding. Every single one of them has to be forwarding. So in data center, we have a few different techniques that we could accomplish this with. One of them would be if you're on non-Cisco hardware, because Cisco hardware doesn't support it yet, you could use Trill. On Cisco hardware, depending upon what type of Nexus switches you're using, you would have the availability of using Fabric Path, which is Cisco's proprietary solution that's very similar to Trill. But with this, we don't really need anything particularly special at the spine layer. At the leaf layer, or down at the hypervisor switch layer, that's where we're going to do our VXLAN encapsulation, and we're going to do what's called MAC in IP routing. So we're going to encapsulate our frames in UDP and route them across the network. And what does that mean? It means that these links right here, every single one of them is a routed link. If you're on a switch, that's no switch port and assign in a /30, or if you're really generous with point-to-point links, you could do a /24 like I did, but in a production network, you'd probably be a little bit more conservative with how you allocate your addresses. But the point is, these are all routed links between the leaf and spine layer, and the fact that we're encapsulating frames with UDP and using VXLAN to forward the traffic means that we can take these frames, encapsulate them in UDP, forward them across the network, and use equal cost multipath to have all these links forwarding, and when they reach their remote VXLAN tunnel endpoints, VTEPs, we're going to strip the UDP header off and forward the frame, and these hosts will be none the wiser. So in the GNS3 lab that I have built out, it's not quite this grand, but I still want it to have 4 spines. So I'll open that up really quick. I have my 4 spines. These are, again, nothing special. They're just 7,200 images. They could be 3,600 images or 3,700 images, whatever you have floating around in GNS3. It just has to be a router that supports any basic routing protocol and multicast. And then down here I have some CSR 1000Vs. These are 4 separate VMs built in VirtualBox, and that's where all the configuration is going to happen. I have these. This switch isn't super necessary. I just wanted to have hosts that were on the same local segment so I could ping between them. But before the VXLAN configuration was done, I wanted to show that, hey, like host 1 can ping host 2, but host 1 can't ping 3, 4, 5, 6, 7, 8. So with that said, I'm going to jump in and I'll give you kind of a quick overview of the existing topology. It looks super complex, but it's actually pretty basic. And after that, we'll do our VXLAN configuration. So I'm not going to show you the configurations on every single one of these devices because it'd be like an hour video and we would accomplish very little. So instead what I'll do is I'll show you the configuration on spine 1. And let me make this a little bit bigger and blow the font up so you can see it. As you might gather by the console prompts right now, I am using EIGRP. It could be OSPF, it could be whatever routing protocol you want it to use. I just use EIGRP because the network statement's super easy. So we can do a quick show run, and we'll section out router. Well, we'll just section out router. There's only one process running. So there's EIGRP, Autonomous System 47884, wink wink, and our network statement is just 10.00. And then we'll jump down and we'll look at CSR1. Show run section router. You can see it's the same thing. Just router EIGRP 47884 is our AS. And then we're going to say network is 10.000. And then the way I have it set up is loopback addresses. And everything up here, by the way, is in the 10.00 network. So as you might have guessed by my network statement. Loopbacks are all 10.0.0 and then the router number. So it's 10.0.0.1, 0.0.2, 0.0.3, 4, and then down here we start over with 11, 12, 13, and 14. So I can look at my router here and I'll do show IP route EIGRP. And you'll see, for example, to reach the loopback address of CSR2, we have 4 equal cost paths. We should have 4. I say 4, but I see only 3. Interesting. All right, because 13 and 14 have them. Hold on 1 second. And one of our neighbors is down. And we paused the video so I can fix this. All right, well, that was super weird. I tried to shut the interface, and the CSR crashed. So we're off to an awesome start. All right, so now when I do show IP route EIGRP, now we have 4 equal cost paths to the loopback of CSR2, CSR3, and CSR4, all 4 equal cost paths. So they're all going to be forwarding. And then the other trick that we have to do to get VXLAN working is we have to have multicast enabled. So the reason we have to have multicast enabled is because the VXLAN standard doesn't really define a control plane for VXLAN. So whenever we receive stuff like unknown unicasts or ARPs, broadcasts in general, VXLAN needs to have a way, or the device has to have a way of mapping remote MAC addresses to specific tunnel endpoints. So the way that VXLAN does this, if it doesn't already have a mapping in the bridge domain, is it sends a multicast out to your specific multicast group that I'm going to configure here in just a moment. And then it finds that MVE peer, and then we have a remote tunnel endpoint for how we can forward frames to it for those hosts going forward, and it's unicast going on. So that's where the multicast component comes in. Not all of your traffic is sent out multicast, only unknown unicast and broadcast. All right, so that being said, we can do a show IP PIM neighbor, and then I'll do a show run on a couple of these interfaces. So you can see we're running in sparse mode, and this is the way it'll look on all of the spines. We're gonna have all of our interfaces facing the leaves will be in sparse mode, and then we can come down to the leaf, and we'll do show IP PIM neighbor. We'll see that our neighbors are there back up to the spines from this leaf. And then we can just show IP PIM RP map. I'm using BSR, by the way, to announce our rendezvous point, and I'm specifying for the group of 23900/8, which is where I'm going to put all of my multicast groups. And really, for this video, it's only going to be one. All right, so we have a fully functioning multicast domain. We can test that, which I highly recommend doing before you start tinkering with VXLAN. Otherwise, you're going to be pulling your hair out. So I'm just going to jump on spine 2. And I'm going to do IPPIM sparse IP IGMP joint group, and we'll just pick some random group that I'm not going to use later. Oh, and by the way, if you want to see my incredibly complex BSR config, it's on spine 1, and that's it. Bidirectional PIM is enabled on all of the spines and leafs, by the way, so spine 1 through 4, CSR 1 through 4, all have bidirectional PIM enabled. I haven't tested it without bidirectional PIM, VXLAN that is, but Cisco recommends that it's on, so I just turned it on. So you can see that all of them have bidirectional PIM enabled, and then on the RP candidate, I specify my group list, then say that this group is going to be bidirectional. So anyway, now that I have this group, 239, 254, 255, or 254, what I'm going to do is just test that multicast is working. I'll just test it from CSR1. I'll try and ping 239, 254, 254, 254, make sure I get a response. Hey, multicast is working. So we can actually pull that off now. Again, if your multicast isn't working, VXLAN's not going to work for this particular lab anyway. There is some config coming in the future where you can use BGP instead of multicast to propagate MAC addresses, but again, for this one, we absolutely rely on multicast. No multicast, no VXLAN. All right, so that's all we actually have to do in the spines. There's nothing else the spines have to be aware of. They're not going to have a route to the 192.168.0.0 domain. I mean, I'll do show IP route. You see that? Actually, the leafs, our CSRs, won't have a route to the 192.168.0.0 domain that these PCs are going to be on either, because everything gets encapsulated VXLAN. So when you have an overlay like that, the core network doesn't actually have to know about this domain down here. Obviously, if these PCs wanted to get out onto the network and go to the internet or something, you'd have to have like a VXLAN gateway or something, but that's something I'll cover in a different video. So since we don't need the spines, I will close out of those consoles. And then all of our config is done right here. So I'm going to test first. Let me just do IP. Does it show IP on these? Yes. So show IP, this is 192.168.0.1, 0.2, 0.3, 0.4, 5, 6, 7, 8. Easy enough, right? PC1's.1, PC8's.8, you get it. So I'll go over to PC1. Since PC1 and PC2 are on the same switch, I should be able to ping between them right now with no configuration needed. But if I try and ping somebody like PC3, it'll come back not reachable. If I try and ping like PC8, it'll come back not reachable. So now that you can see there are no shenanigans thus far, what I'll do is I'll jump in, I'll do the VXLAN bridge configuration. It's not super complex. So I'll go into global config. We have to configure our MVE interface. I'm just going to do MVE1 because I don't have any other MVEs. And then we're going to specify a source interface. Source interface is going to be loopback 0 for all of these because you don't want to necessarily pin it to a physical link in case one of those links goes down. So we'll pin it to our loopback 0. Then we're going to... Actually, I'm going to check my syntax on this. So source interface is loopback 0. We have to specify a member VNI. So, you know, another benefit to using VXLAN is with VLANs, you're limited to 4,096 segments. With VXLAN, you get over 16 million. As you can see here, our segmentation ID, our VNI, can be anywhere between 4096, which starts right at the very top of your VLAN range and goes up to 16 million and all these digits that I'm not going to read to you. So for this lab, my VNI is going to be 6010. And then we have to specify a multicast group. I'm going to use the multicast group of 239.060.10. And then I'm going to no-shut this NVE. So I'll do a show run int NVE1 because we can actually copy and paste all these configs and save a little bit of time. So no-shut. Next thing we have to do is we're going to configure the interface that's facing our top of rack switches down here. This is gig 5 on all of my CSRs. So again, we can save a little time and just put in Notepad and copy paste. So it's going to be int gig 5. We have to specify a service instance. You have an identifier here that can be between 1 and 8,000. I'm just going to choose instance 60. We're going to say the type is Ethernet. And then inside here, you have to tell it what type of encapsulation that you're going to use. I'm actually going to no-shut the int too. This is all going to be untagged traffic. You can use a VLAN in here. And you can have multiple service instances per single physical interface. But again, this is going to be a pretty basic VXLAN lab. So I'm just going to say encapsulation is untagged. I'm going to exit out of that, exit out of the interface config, and then I'm going to type in bridge domain. The bridge domain, you have to match the VLAN tag that you specified up here. Since this is untagged for my lab, it's just going to be bridge domain 1. And then I'm going to have to check by syntax again. So let me just go ahead and copy and paste all of that in. I'll wait for gig 5 to come up so I don't get interrupted by the console prompt. Any day now. Actually, I think gig 5 is already brought up on this. Okay, so I'm going to say member is gigabit interface 05. The service instance that I specified was 60. Then I'm going to say the member VNI is 6010 as we specified in the NVE interface config. By the way, this NVE, this is your VXLAN rather, your VXLAN tunnel endpoint. So this endpoint is where all the multicast, or where the encapsulation for VXLAN happens and how we're forwarding out to that multicast group. So this bridge domain, we're just tying everything in together now. I don't think you have to no-shut it, but I no-shut it anyway. So we can do show run section bridge domain, if I can type. And we'll bring all of our config into Notepad here. So again, interface NVE, the interface where you're expecting frames to come in that you want to encapsulate VXLAN. A service instance, what type of encapsulation you're expecting. Again, this is all untagged traffic for my lab. And then I have bridge domain 1 because it's untagged. Tying it back to that VNI we specified under the NVE interface. And telling the bridge domain that the member interface is gig 5 and service instance 60. And that's it. So we're going to copy and paste that on all of our CSRs. Boom, done. We'll do a couple show commands before I do any tests from the PCs, just so we can see a difference. So we'll do show NVE interface, NVE1, detail. We got 0 packets in, 0 packets out. I'll do show NVE peers. We have no peers yet. And then I'll do show bridge domain 1. And we have no MAC addresses learned yet. So what I'll do is I'm going to go over to PC1. I'll try and ping that 192.168.0.3 address that failed earlier. And we'll see it immediately comes up. We'll come back over here. I'll do show interface detail again. You can see that we had 4 packets in, 4 packets out. I'll do show NVE peers. We have our first peer, which is CSR2. and then I'll show bridge domain 1, and you can see that we learned this remote MAC address of 6802, and we have it via destination 10002 and with VNI 6010. So I'll go through and I'll ping a couple of these, and we'll just build out what our domain looks like. I'll get it from that guy, that guy. I pinged him already. Okay. So now if you look at bridge domain 1, we have a pretty well populated MAC address table. We have all of our different VTEPs in here from the remote pods. And that's it. I mean, I was trying to think if there's anything else that I can add in for this, but for a basic VXLAN lab, that's all you have to do. We can do a show IPM route, and you can see our bidirectional PIM is up and working. Here's your star comma G for that 239.60.10. If we looked at the spines can see that also. Star comma G, we have our outgoing interface list. And again, these CSRs are forwarding traffic between our different top-of-rack switches over a routed network, but they have no idea where 192.168.0.0 is. And that's because it's all encapsulated VXLAN and tunneled over our existing routed network. So that's it for this video. Plans for future VXLAN videos is I'll show how to turn these CSRs into VXLAN gateways so we can actually bridge our VXLAN domain onto the physical network. So if you wanted to do stuff like get hosts off of their VXLAN domain and off to the internet to remote sites, we can do that. And then I'll show mapping multiple service instances to a single interface. And also, this particular lab that I did, I only have one rendezvous point. So what I'll probably do in the next one is I'll set it up so all 4 spines are doing Anycast RP and doing MSDP, so they're sharing sources between one another. So that's all for this one, and I'll see you guys next time.